Hey folks, welcome to my channel Number Pen. We have the problem on our screen. Find the points at which f is discontinuous. At which of these points f is continuous from the right, from the left, or neither. Sketch the graph of f, right? So we've got f of x equals x minus 1 the whole cube, comma x less than 0. And we've got x plus 1 the whole cube for x greater than or equal to 0, right? So, like we've done in the previous problems, right, we will have to approach this problem in parts, right? And what is our part one in this case is pretty much evident is our x lesser than 0. And what do we mean by x lesser than 0? We mean that x belongs to the interval minus infinity to 0, right? So let's write that down. X belongs to minus infinity 0, and this is the open interval, folks. And what is our f of x in this open interval minus infinity to 0? It takes x minus 1 the whole cube, right? So now I want to draw your attention to a theorem called composite theorem of continuity, right? I thought this is a good example to talk about that particular theorem on continuity. And what does that theorem say? I'll just write it down here. F and G are continuous functions. Okay. And if F and G are continuous functions in their proper domain, let's assume let that be it in any domain, right? Then my F dot G, right, also is continuous, right? Is also continuous. That is what our composite theorem states, right? Now, drawing your attention to continuity of basic functions, right? We know that x cube is continuous, right? So if I want to call my f of x equal to x cube, right? If I'm going to call my f of x equal to x cube, right? Then the function that we have been given where we will have to examine continuity is x minus 1 the whole cube, right? So what is going to be our g of x if I want to relate this to the composite theorem, right? So I'm going to call this out as composite theorem, right? Composite theorem. And so basically what it states is f and g are continuous functions. Then my f dot g is also continuous. And what is my f dot g? It is nothing but my f of g of x, right? Right. And what is my g of x in this case? X minus 1. So I know that x minus 1 is a linear polynomial. It is continuous. F of x equals to x cube is continuous for all x belonging to R. So I'm confident that my f and g are continuous, and therefore from composite theorem I know that my f dot g is also continuous, right? So let me write that down. Yes. And what is my f dot g? F of g of x. And what is my f of g of x? Wherever I have x in my f of x, I replace it with g of x, right? And what is my g of x? My g of x is nothing but x minus 1. So my f dot g becomes x minus 1 the whole cube, which is indeed a continuous function, right? Is therefore continuous for x belonging to minus infinity to 0, right? So there we have part 1. Notice that the function undergoes a transformation from x minus 1 the whole cube to x plus 1 the whole cube as we move through 0, right? So we will have to examine the continuity at the point x equal to 0. But before doing that, let's do x greater than 0, where what we mean by x greater than 0 is x belongs to the interval 0 comma infinity. And remember, this is the open interval. And again, I have an application of composite theorem here. I'm gonna just copy this, and what is it in this particular view? So So my composite theorem again, I don't want to repeat this, so I'm going to just use it as it is, except that my g of x in this case is plus 1, right? And I used f and g because that's the common nomenclature which is used. But specific to this problem, maybe I think I should change this, right, to avoid confusion. So let me do this h dot g, and I mean that h of g of x. And similarly, if I assume my h of x equals x cube and my g of x equal to x minus 1, my h dot g is also continuous as per composite theorem, and my h of g of x is x minus 1 the whole cube, and therefore it is continuous function, right? And what is our h of g of x? It is nothing but our f of x, right? Similarly, I have my f of x equals x plus 1 the whole cube, and I can use the composite theorem here again to establish why my x plus 1 whole cube is also continuous. So without going into much of detail, I know that x cube is continuous, and my x plus 1 being a linear polynomial is also continuous, and therefore for my part 2, which is x plus 1 the whole cube, it is continuous in the open interval 0 to infinity, right? I'll just pause here for a minute, folks. uh, so all that we have done is applied composite theorem for x plus 1 the whole cube and x minus 1 the whole cube. And composite theorem states that if h and g are two continuous functions, then h dot g is also continuous, right, in its domain, right? So, and which is the domain here? For x minus 1 the whole cube, we have our domain as minus infinity to 0, and for x plus 1 the whole cube, we have our domain as 0 to infinity, right? So that's how we uh, this I thought this is a good example where we can apply the composite theorem and discuss continuity of this function, right? So I'm going to go to part 3 where we have our x equals 0, right? So what is our f of x equals 0? What is that? Our f of x equals 0 means we'll have to use x plus 1 the whole cube, right? Because that is what we've been given. And what is x plus 1 the whole cube? Which is 0 plus 1 the whole cube, which is nothing but my 1 cube, which is 1, right? So let me write that on the whole cube, which is 1, right? So I'm done with that. Now let's approach f of x from the left, right? So let's start with LHL. So what are we going to do now? Establish the LHL, right? So I'm going to pull out my limit. And what is our limit as x tends to 0 minus? We have x minus 1 the whole cube, right? That's the function. Because for x less than 0, we are approaching 0 from the left. So the function will take the value x minus 1 the whole cube. And what is it? It is minus 1, right? And why is it minus 1? Because what is my 0 minus h? What is my 0 minus? So I do a 0 minus h, where h is infinitesimally small, right? And when I do that, all that I get is 0 minus h minus 1 the whole cube, which is h equals 0, which means we are at minus 1 the whole cube, and therefore we have minus 1, right? And let me also this, right? And now I move to my RHL, right? And what is my RHL? My RHL is f of x equals 0 plus, right? And how do we do that? All that I need to do is extending to 0 plus and have x plus 1 the whole cube and 0 plus h plus 1 the whole cube, right? And therefore I have it as plus 1, which is 1 cube, right? So I know that when we approach 0 from the right, which means that x is going to take a value which is slightly above 0, and we represent that as 0 plus h, where h is infinitesimal and extremely small. And therefore when I do that substitution, we notice that we have our x plus 1 the whole cube becoming plus 1, right? So we have our LHL, we have our RHL, right? So in this particular case, and I wanted to draw your attention to what is being asked in the question, right? So the question asks find the points at which f is discontinuous, right? And at the same time, he's also asking us to find out at which of these points f is continuous from the right, from the left, or neither, right? So I wanted you folks to give it a thought before concluding that it is discontinuous at the point x equal to 0. And why is it discontinuous? Because my LHL not equal to RHL, right? LHL not equal to RHL, right? And LHL not equal to RHL, which means limit does not exist, and actually is discontinuous at x equals 0, right? But then again, coming back to whether the function is continuous from the left or continuous from the right, or discontinuous from the left or discontinuous from the right, right? So how do we look at that? So I notice that my LHL, which is I approach 0 from the left, right? I'm at minus 1. And then when I hit 0, the function takes a value 1, right? That is what is f of x equals 0, right? And after that, when I cross 1, my RHL takes a value 1, right? So from the point x greater than or equal to 0, I don't see a challenge, right? Because my f of x equals 0, uh, f of f at x equals 0 is equal to 1, which is equal to my right hand limit, but my left hand limit is minus 1, right? So where is the function actually discontinuous from? It is discontinuous at x equals 0 and from the left, right? So that is how we will have to express the final answer. But whatever said and done, the function is discontinuous at x equal to 0, because at x equal to 0, the graph exhibits a break, right? That's what it means. It moves from minus 1, and then when we hit 0, it is at 1, and then beyond 0, it takes the value 1, right? So I mean, I'm talking about immediately beyond 0, it takes the value 1, right? So there is indeed a break at x equal to 0, which means that when you draw the graph of this function, you will see that there is a discontinuity at x equals 0, and therefore the function is discontinuous at the point x equal to 0, and the discontinuity is from the left, right? So that is how we will have to call out the answer for this particular question. I hope you found this video useful. Please do subscribe to my channel and support. Thank you.